So in this video I'm going to look at the solutions for the trig graph transformations questions that I posed in the previous one. I'm going to look at how we approach them, what each of the transformations does, and how the final product should look. Quick refresher for you though in terms of what the questions were. So these were the three graphs I wanted you to sketch, all for between x being from 0 to 360 degrees. So let's break these down, have a look at them one at a time and see how we go about it. So the first one is y equals 3 sine 2x. Now, remember, when we've got one like this, we have to look at the transformations in order. We have to see how it changes. Now remember, the generalized way we had it was y equals a sine of bx plus c, then plus a d. And we said to ourselves there was a certain order we'd look. First order was what happens to the x there. Second order was then what happens there. Third part was what happens with the a. And the fourth and final part was what does this plus d do to it. So this was the order we approached then. So what that means is for this graph, we have to think about what this does first, and then what that bit there does. Well, this one here affects the x direction. So sine 2x, remember that means we compress the graph in the x direction. And we essentially make it repeat itself that many times in 360 degrees. So what we do with this one, in essence, is we take the graph and repeat it twice in 360 degrees. So you could imagine we've got our axes here. We just take the graph of sine x, and there would be one repetition of it. But because of the 2x, we then repeat that again. So we go over the period the exact same way again. And it would be there. So our end of our initial one's at 360. Here it's now at 180. Second curve finishes at 360. And these halfway points go halfway as well. So this was at 180, it's now down at 90. And this one here was at what would be the equivalent of 90 in the second repetition, but it's now 270 here. And our maximum and minimums would occur at their new parts here as well. So there would be 45, 135, write these in, 45, 135, 225, and then 315. So that's what that one does. Now this one here stretches and squashes the graph in the y direction, changes the amplitude of it. And remember, if it's a number bigger than 1, it stretches it to that new limit. So our limit originally with the sine curve is 1 and minus 1 in both directions. Well, what this does is it stretches it to 3 and negative 3. So what this then does is gives us a curve that looks something like that. So what this means is that I've now done my sketch and I just have to make sure I label it. So y equals 3 sine of 2x. That there is my curve sketched out, drawn on a new set of axes and labeled. Now that's a lot of information to put in there. You could get away with leaving some of the key points on, so maybe where it cuts the x-axis would be the key ones to leave in, and marking on its maximum and minimum. When you get ones like this, make sure that you put the information on, but you don't clutter your graph too much. Second one was y equals cos of x plus 60 minus 1. Now think back to the order of operations we did when we were shifting things around with the graphs. Same thing applies here. So same thing applies when we had y equals a cos of bx plus c, then plus a d. It's the same order we look at it. So what first thing we look at would be the b, then the c, then the a, then the d. Now there's no b in this case, there's nothing in front of the x, so that's fine. The next thing we look at is this plus c, so this bit in here, and then the minus 1 after that. So we see how that affects it. Ones like this, it's worth approaching it one step at a time. First one was fairly straightforward, so we could do that all in one go. This one is more worth approaching it one step at a time. So y equals x plus 60. Now remember, that shifts it left or right on the x-axis, but it does it the opposite direction. So plus, we would expect the graph to go up x, but actually x does the opposite, so it shifts the graph down. So instead of cos starting here at 1 and minus 1, this one would shift along here 60 degrees. So we'd actually be starting somewhere about here for the general shape of our cos. We'd come back up to a maximum at 1, but because remember we're going between 0 and 360, we have to continue on until we hit the value that would be at 360. And this one would be the equivalent height of where we started. Think back to the cos. It starts at 1 and finishes at 1, so that's where it would be. Minimum would still be at -1, and the maximum would still be at 1. We just have to now think about the key bits of information that we have to mark on. Well, this one here was at 90, it's now down to 30. The minimum was at 180, it's gone down 60 now to 120. This one here cut the x-axis at 210 originally. Sorry, 270 originally, it's now gone down to 210. And the maximum back here did occur at 360, it now occurs at 300. So this would be our y was cos of x plus 60 part. We've now got to do the -1 bit. So we've now got to take this entire curve and shift it down 1 to get our final version that we're after. So in doing so, focus on the maximum and minimum. So the maximum, if we shift it down 1, would go onto the x-axis, and our -1 would go down to 2. Down to -2. So it'll go down to about there, it'll go back up to there, and then back down to about there. So again, that's the equivalent. That there, our new minimum, is down at -2. Our maximum hits the x-axis because it's now down to 0, and we've still got the same other information for the x. Now it's maybe worth just noting on where the minimum occurs, so at 120, and where the maximum occurs at 300. So that would be what it would roughly look like. So that there would be a good sketch of why it was cos of x plus 60 minus 1. So that would be the graph we're after. Final graph I wanted was why it was tan of a half x minus 45. So again, break it down and look at it in stages. This would be the first thing we have to look at. This would be the second thing we have to look at for a change in a transformation. Nothing here, and no number in front, but remember tan, if there was a number in front, it really wouldn't make a difference to it because tan stretches off and goes off to infinity in the y direction and negative infinity in the other. So this first one here is a half x. Now remember, that stretches or squashes it in x, and it tells you how many times in 360 degrees that curve repeats. Well, it goes a half of what it does. Now tan repeated twice in 360 degrees, so in this case it's only going to get one repetition in the 360 degrees. So the curve for tan is going to look the same way it did there. There's the discontinuity that we would normally get, and then it would come back up and go to there. But that's what it would look like. It would only repeat once in 360, and these bits here would get stretched. Now this was at 90, that would stretch out to 180 degrees there, and that would be the tan of a half x. We've then got this second transformation to do, the minus 45. Now remember, this transforms it in x, but we do the opposite. So we're taking away, it doesn't mean we go down the axis, we actually go up. So everything here moves up 45 degrees. So we can draw a new set of axes down here for our final one, and we know that it's actually going to start down here. And it's then going to go up and cut the x-axis, and it's going to cut the x-axis at 45 degrees. It's then going to go and shoot off to infinity, like we would expect it to. There again is our discontinuity, and then it's going to come back up from there, and finish up there at what would be the equivalent of where the 45 degrees was, at 360 there. And again, we can mark on the key bits of info. Well, we know where it cuts there. We could also mark on this as 180 going up to 45 degrees to 225. Then label it. Make sure you give it a name. You can't get away with not doing that. So make sure you say, right, so y was tan of a half x minus 45. We've got our final drawing, we've told them what it is. We have to remember all these transformations and transfers of the graph and how we're able to do them. This is what you need to be able to do for this sort of stuff. Hope that went well. I shall see you in class.